So, enough talking, let's get straight into it. We have been studying different lessons quite lately now, and today's lesson is about vector addition, how we add vectors. So, we reviewed this topic quite a lot in the previous lessons, how we add it, but we haven't really thought about it very clearly. So, let's just think about it. So, let's say I have two vectors, a vector A right over here and a vector B right over here. Now what I want to do is I want to add those two vectors. So in case of adding the two vectors, you got to remember that you have to add the head of a vector to the tail of another vector. That is very important. So the head-tail method says to us that we have to add the head of a vector to the tail of another vector. That means the final point of a vector to the initial point of another vector. So when we add those two up, we get that vector A plus vector B will be equal to what? So let's say, let's shift them. We learned about shifting quite a lot. So we had a vector A and we shifted vector B right into it. So the initial point of vector A and we have the final point of vector B. Now we add those two up. This is our resultant vector R. So A plus B, it gives us R. Now what about B plus A? So let's say I want to add B to A. I don't want to add A to B. I want to add B to A. That means I want to cover this distance first, then I want to cover this distance. So let's say I went B first. So I went B. The line is not being straight. That's very frustrating. So yeah, I went to B first. Then I chose the direction of A. Then I went A. So what will be the resultant here? So this is the B vector. We have its initial point. This initial point. And then we have the A vector. And we have its final point. So we have to so we have to add them up. So we added them up with this vector, and let's say that vector here is P. Now look closely. So let's look at R and let's look at this P vector. Aren't they similar? They are not only similar, they're also the same thing. I mean, what I'm trying to say is R is just equal to P. That means this I draw very flawly, so it doesn't really seem that way. But actually, if you just erase the A's and the B's right here, you'll see that the R and the P are the same vector. It is going in the same direction, and it also has the same magnitude. So that means what we can say is also if we add B with A, if we add the B with A, we also gonna get the R. So that is what I'm trying to say. That vector addition, it follows general rules. General rules means the rules that applicable for everything. Let's say 2 plus 3, it gets us 5. Also 3 plus 2, it also gets us to 5. So the addition of vector, it follows the general rule. And now let's create another problem. That's what we do. We create problems, then we try to solve it. So let's say we have those three vectors. We have this vector A right over here, but it's in this direction. And then we have a vector B right over here. but that's in this direction. And then I say we have another vector here. Let's add some plot twist to the story. There's a vector C right over here. Now my question is, what is A? Let's use the same ink. So what is A plus B plus C over here? What is this? And also I want to find out what is B plus A plus C over here. You get the point. Or also I want to find out what is C plus B plus A over here. So I just took these 3 points. So you can also add different scenarios right here, but I'm just initially taking these 3 scenarios, and I will go through them all at very shortly. Go through them, and so let's just dug right in. So let's just go for the first problem. A plus B plus C vectors. So yeah, we have vector A right here. So with the head of vector A, I add the tail of vector B. So that takes us right over here. This is our vector B. Now with the head of vector B, the same way we add the tail of vector C, it takes us right over here. Now we have the final point of the final vector and the initial point of the initial vector. And now we just add those things up. My drawing is really bad right here, but you get the theory, okay? That's straight lines. So that's the R resultant. So the resultant here is R. Now let's look at the different scenario. The B plus A plus C. So now I add the B here, right over here. That's the B. With the B, I added A. So with the B, I added A. A will go right over here, down the stream. That is A. And with the A, I add C. So for the C, it will just go right over there. There it goes. The C over there. Now, we have the final point of vector. So yeah, let's just take the initial point of A, and this right here is our R, and you see that these are similars, but due to my drawing faults, this doesn't seem similar, but these are similar. That means these are the same thing. Now we can also do that for C plus A, since we have this C right over here, and then we added B to it. So B would just go right over here, and that's the B. That was the C. And then we add A to it. Now let's say A will go in this direction right over here. That is the A. Okay. And now when we join these two up, we'll get something like this, which is the R, and it is also R. So what you can do is you can also represent in two different types of things. Let's say you put A and B into the same bracket. So that means you first determine the A and B. So that will be just right here. You determine the A and B. And then we have this, let's say the P or the A and B, okay? So this is the, let's say, R, and the R and C is now the R. So this whole thing will be the, sorry, the P, it was P. If you think of it as a different type of thing, if you add them two up first and then add C, you can also do this. But let's just don't get into the more advanced topics. Let's just don't dangle our heads together at first. We just have to find out the beauty of vector. You have to find out the concept, the basic things about vector, just appreciate its beauty, and so on. And in the next video, we'll try to learn about the the subtraction of vector in more details.